What's going on, and welcome to my channel. Today we talk about the various APIs that exist for Spark SQL. Now the question is there any major difference with respect to performance, monitoring, functionality, or anything like that, which depends on the API which I use? Now, as you may know, we have an architecture like this where we have Spark core as the foundation and the execution model, which some other high-level abstractions have been added on top on. For example, Spark SQL is an abstraction built on top of Spark Core, and we can use it from SQL, Python, Scala, Java, or R. Now, while Python and Scala are the most prominent languages we use to implement Spark applications, there's another player, which is SQL. Now, Python and Scala are programming languages, and Spark being written in Scala itself. Now, we use an external dependency to Spark if we use Python or Scala to build actually structured code to tell Spark what we would like to do. In a sense, we use the Spark SQL API from within our code to actually tell Spark how to transform the data and how to and Spark will actually translate these transformations into an executable workload which it can execute on a cluster. Now, SQL takes a quite unique role here because it's a database querying language, so that makes it different from Python or Scala. And the question is if there's any difference in the execution of the query if I write them in if I write it in Python, Scala, or SQL. And the simple answer is no, there's no difference at all. And if that's the answer you will be looking for, you can stop this video right here. If you would like to understand why that is the case, you can stay tuned. Now, whenever we build an application with Python or Scala, as I said before, we use the Spark SQL API to call transformations on the object of a data frame, which is the central data abstraction, distributed data abstraction we use in Spark SQL. And on there, we call basically transformations to assemble a query plan to tell Spark what we would like to do with the data. Now, internally, Spark assembles an internal logical and abstract representation of our query, also called the logical plan. And here you can see a logical plan. Basically, we read two CSV files, then we project some columns, add a new column, then we join the two data frames, we filter, and then we call an action. And that's what Spark creates out of the API calls we basically make against the API. Now, this logical plan actually contains all of the information Spark needs to execute this query plan on a cluster. So that means attributes, the order of the operators itself, where to find data, and so on. So this logical plan is actually sufficient and basically a sufficient representation of our query. Now, if we use SQL to write a query, the very same thing happens. However, we have to add an additional step before we assemble this logical plan, which is that we need to parse and understand the SQL query that we hand over as text. And therefore, Spark actually has implemented an entire SQL query interpreter, which basically parses the SQL query and transforms it into the very same logical representation, which we can build from the programming language APIs directly. So the answer to the question, if there's any major difference in using any of these APIs, is no, because all of the APIs that we can use actually yield a logical plan, which is an abstract logical representation of our query. All right, having that said, I would like to suggest everybody learning Spark, or actually using Spark, to use a proper programming language. Using a proper programming language actually allows you to use a proper development setup. You can use all of the vast amount of features available from IDEs to structure your code, to write clean code, to test your code, and things like that. Also, compile time safety. So if you just throw in a piece of text, which is supposed to be a SQL query, you can fail at runtime, whereas the IDE will tell you if you use an undefined symbol in your Spark code using Python, Scala, or Java. So you get compile time safety. And yeah, I would argue to write actually complex workloads, it's much, much easier to structure that code with a proper programming language. If you would like to become a Spark Pro very fast, I offer individual coaching. You can find it at academy.philipp-brunenberg.de, and I will teach you in 12 weeks everything you will need to know to become a professional Apache Spark software engineer. I hope you enjoyed this video and see you next time. Until then, bye bye.